All right, so we're going to take a little mini shortcut here, and we're going to touch on things called transformations. We're going to focus on reflections, translations, and rotations. Those are the three that we're going to talk about. So reflection is like a flip. When you look in a mirror, it's like a mirror image, the same thing on both sides. A translation is like a slide. You're just basically shifting from one side to the other, left or right or up or down. And a rotation is a turn. So I'm going to go over the rules for each type. So when we talk about a reflection, there's 3 types of reflections that you're going to see in this class. There are many more, but these are the 3 that we're going to focus on. So you can reflect a point in the x-axis, which means you're going to multiply its y coordinate by -1. So the rule for the x-axis would be right here. So you're going to start with the point xy, and then it's going to become x negative y. When you reflect something over the y-axis, basically we're taking the x coordinate and we're multiplying it by -1. So the rule is you're going from xy to -xy. And then the final one is if you're reflecting something over the line y equals x, which is basically where you switch the x and the y. So that got cut off, so let me write the rule here. So you're going from xy to yx. So nothing's changing in terms of signs. It's just the values flip-flop places. Now, those are the 3 rules. Those are the main ones, I would say, but you are going to encounter things where you have to reflect something possibly, let's say, over a horizontal or a vertical line, which is the x and the y-axis, but they're going to be written differently. So it's going to say, for example, triangle JKL has vertices J is at 0, 3, K is at -2, -1, L is at -6, 1, and we're going to graph triangle JKL and its image in the line x equals -4. So that does not sound proper in terms of math, but it is. So when they say in the line, that means a reflection over. That's just mathematically how it's written. So x equals -4 is not the x-axis, it's not the y-axis, and it's not the line y equals x. So if you encounter a question where it's telling you to reflect something over any other type of vertical or horizontal line, what I would suggest doing is first plot the original values, J, K, and L. So let me just shade those in. So here's J, K, and L. So again, be able to plot them. Then the line x equals -4, that is a vertical line right here. And there's no set formula for this, so the best thing you need to do, you just count. So you say, okay, well, how far is L away from that blue line? Well, it's 2 units to the left of that blue line, which means if this is a mirror image, it needs to be 2 units to the right of that blue line. For J would be 1, 2, 3, 4 units away, which means if it's 4 units away on the right, it needs to be 4 units away on the left, and you create your new point. Now, if you notice, these new points, they have the same letters, you just have that little tick mark there, which basically represents something called prime, and it's the image of where you're ending up with. So the image is where the final triangle finishes up, but you want everything to be labeled. Now, in terms of K is again 2 units to the right of the blue line, which means K prime needs to be 2 units to the left. And then what you should be able to tell is after you plot that triangle, if you were to fold your paper right on that blue line, that green triangle and that red triangle, they should match up with each other perfectly. Okay, so again, if it is not one of the 3 rules that we just went over, you're going to have to actually count. Same thing would go for a horizontal line. Now, what I do want to do, though, is just give you one instance. I want to show you a mapping situation here. So I'm just going to go down to this blank page, and I'm going to add an example. So let's just say we're going to take the points. A is at 2, 3. B is at -4, 5. C is at 7, say -3. And we're going to reflect triangle ABC over the x-axis, or it might say in the x-axis, which you need to know means over the x-axis. So what we're going to be doing a lot of is we're going to be making these things called maps. A map is sort of like a chart that just has all the information in it. So first thing I always recommend doing is taking your original points, x and y, and that's going to be your first column. So we just recopy. We don't have to graph it unless it tells you to graph. And I'm just recopying the original points. Now, I know something's going to be done to each of these points. A is going to end up at A prime. B is going to end up at B prime. And C is going to end up at C prime. And so if I know that the rule is it's being reflected over the x-axis, I go back to the rule that says, basically I take the y-coordinate and I multiply by -1. So I'm reflecting over the x-axis. So my x value stays the same, but my y value gets multiplied by -1. So 2, 3 becomes 2, -3. -4, 5 becomes -4, -5. And 7, -3 becomes 7, +3. So when you do your work, I need to make sure that I can see this chart. This chart is very important, and if it asks you to graph, then that's an extra thing that you're going to have to do. But I do expect to see these maps when you do out each of these questions, unless it is reflecting over one of the lines that is not one of the rules. But anytime you're reflecting over the x-axis, the y-axis, or the line y equals x, you have to make one of these maps. All right, so that was type 1. So type 2 now is a translation. So it says to translate a point along a vector, because you always translate a vector, A, B, and this is what a vector now looks like with these little pointy brackets. You're basically adding the A value to the x coordinate and the B value to the y coordinate. So here's your rule right here. So I think translation's the easiest. And we're going to focus just on the map aspect of it instead of focusing on the graphing. So we're going to identify the image coordinates, which is where you end up, of triangle EFG with vertices E is at -7, -1, F is at -4, -4, G is at -3, -1, and then you have your translation vector of 2, 5. So you make your map. First column is always the original coordinates, x, y. So those you just recopy. Then it says we are translating something over the vector 2, 5. So you can set up your map just like we had done the previous example. Set the whole thing up and then just leave the right column blank, because that's what we're going to need to figure out. So we have our original coordinates. We are translating something over the vector 2, 5, which means that we're going to take the 2 and add it to our x value. So I'm going to do all the x's first. So every x value, I add 2 to it. So -7 becomes -5. -4 becomes -2. -3, add 2, you get -1. So our x's are done. For the y value, we're going to add 5 to it. So -1 plus 5 is 4. -4 plus 5 is 1. -1 plus 5 is 4. Giving you your new points. So these were positive values in your vector. Let's say it was negative. If it was negative, you would just subtract. So same idea, you're just subtracting the value rather than adding it. But again, it's not asking for graphing, so this map is exactly what I'm looking for, and this is your work. And I would even recommend putting the arrows there. All right, third and final type that we have to go over is a rotation. So there's 3 types of rotations. And what you have to be careful about in math is that the counterclockwise direction is the positive direction. Most people assume it's the clockwise, but it's actually the counterclockwise. Okay, there are many other types of rotations that you can get besides 90, 180, and 270, but these are the three we're focusing on, so you don't need to worry about the other ones. And we will always be focused on rotating about the origin in this class. All right, so it says triangle peak. Oh, sorry, let's do rules first. All right, so we have 90, we have 180 or 270. So 90 goes from x, y. You flip the two values, and the first value changes signs. So you get negative yx. 180, the xy stays in the same spot, but they both change signs. And 270, the xy again, they flip-flop places, but now the second value changes signs. So don't think just because you see those negatives that means that they have to become negative. All that means is the sign changes. So just be careful with that. All right, let's do one of these. So it says triangle PQR has vertices 1, 1, Q is at 4, 5, and R is at 5, 1. We're going to graph it. So you're going to plot your points, and you're going to connect your points, and you make your first triangle. In addition to that, make your first column of your map. Those are the original coordinates that you started with. Then for a rotation, it's telling us that we're going to rotate it 90 degrees. So the rule for 90 is going to be negative y comma x. So again, I'm going to do, well, it doesn't really matter which way you go, whether you choose to finish the point or do one at a time. It doesn't matter. So for P, again, they flip places and the first value changes sign. So the 1, 1 becomes negative 1, 1. The 4, 5, they flip places and the first value changes signs. So negative 5, 4. For 5, 1, they flip places and the first value becomes a different sign, which is negative 1, 5. So you have your three new points, which you can then plot. And what you're going to find is we know that the axes, the x and the y axis, they're perpendicular to each other. So if we are rotating something in the 90 degrees, that's actually going from the first quadrant to the second quadrant. Again, counterclockwise is your positive direction, but you're going from here to here, which is basically a 90-degree turn because you're going one quadrant. If you were going from quadrant 1, say, to quadrant 3, that would be 180. If you were going from quadrant 1 to quadrant 4, that would be 270.